All right, welcome once again to our study of quadratics. Today we're going to be looking at translations or translating parabolas. Another name for this is vertex form. So we're going to be looking at vertex form of a quadratic function and what we can do with vertex form and everything that goes along with it. All right, so let's go ahead and begin. We have just looking at vertex form as translation of a parent function. This is our standard vertex form. It's a times the quantity x minus h squared plus k. And with that square, that verifies that this is a quadratic equation or a quadratic function because this x will eventually get squared when we FOIL. So this is a quadratic function in vertex form. H comma k is our vertex. H represents the horizontal shift, and if h is a positive number, then it moves the function to the right, the original ax squared to the right. If h is a negative number, then it moves the function to the left. If h is our horizontal, that means that k is our vertical translation, and if k is positive, it moves up, and if k is negative, it moves down. All right, so let's look at what this means in an actual example. If we were to give the function y equals 2 times the quantity x plus 4 squared minus 7, we can look at this and we can say that the h, or the k, is my minus 7. And because originally this is a minus h, that means that 4 is actually a negative value. This is actually, to write it in that standard form, 2 times x minus, because that's what we want over here, a negative 4. And we can go from there and say squared minus 7. So this actually shows that the h value is a negative 4. So if we were to look at this, this tells me that h is negative 4 and k is negative 7, which means our vertex is the coordinate negative 4, negative 7. And you're going to be able to look at these parabolas or these vertex form problems and say automatically the vertex is negative 4, comma negative 7 just by looking at them. You won't have to think too much. What this does is it shifts the parent function, which is originally the ax squared, so it's 2x squared. It moves it left 4 units and down 7. So essentially, if we were to go to graph, which we'll be doing here in a few minutes, instead of having a vertex at 0, 0, it moves my vertex left 4, down 7, over to negative 4, negative 7. All right, so the new vertex is going to be down here, and then it's going to do some sort of parabolic shape. But we're not doing that yet. All right, so let's look at one more really quick. If we were to look at negative 9 times the quantity x minus 13 squared minus 8, we can look at the fact that this is a minus, so that means that that is a positive 13. And so the vertex is 13, comma, negative 8. And if we talked about it as translations, this would mean I'm going to take the 9x squared and I'm going to move it right 13 units and down 8. All right, so we're going to be using this knowledge when it comes to graphing, which I believe is right here. So we're going to look at how to graph a quadratic function using vertex form. So what we're going to do, a little how-to, we're going to find and we're going to plot the vertex. We're going to find another point, and more often than not, you can find your y-intercept. Recall, y-intercept means x equals 0. So we can set x equal to 0 so we can solve for the y-intercept. And as soon as we have a y-intercept or another point, we can find the corresponding point across the axis of symmetry as we did in the last lesson. So let's look at this example. We have -1/2 times the quantity x minus 2 squared plus 3. And we're going to look at the graph here. All right, so we're going to find the vertex. The vertex in this case is, this is a -2, so that's a +2. And that's a +3, so that's a +3. So my vertex is at the coordinate 2, 3. All right, so we're at 2, 3. Some things we remember from yesterday's, or the previous lesson, is the negative means this is going to be a downwards parabola. It's going to be downwards like this. That's just so we remember what our graph is supposed to look like. I need to find another point, and I like to try to find the y-intercept just because it's a good point to know where it is. So it's going to be 0, something. I don't know yet. I have to actually plug it in. So I have to say y is equal to -1/2 times 0 minus 2 squared plus 3. So here I get -1/2 times 0 minus 2 is -2, squared is +4, plus 3. And then -1/2 times 4 is -2, and -2 plus 3 is a 1. That means my y-intercept is the coordinate 0, 1. And we're going to plot that. And if you recall, the axis of symmetry is the line that goes through the vertex. And we can use that axis of symmetry to create the other dot, the other coordinate that corresponds to the y-intercept. And since we go 2 left, we got to go 2 to the right, and it's going to be right there. And once we have those points, we can do our best to draw a parabola. Oops, missed. Okay. And there's our parabola. That is the function -1/2 x minus 2 squared plus 3 from vertex form, finding the vertex, finding another point, and then plotting the corresponding point across the axis of symmetry. All right, let's keep moving forward here. We have converting. We have converting from standard form to vertex form. So this is pretty important to know how to do because it actually helps you graph a little bit easier. What we're going to do is we're going to calculate the vertex of the function and essentially put the function in vertex form. So here we have the standard form function, 2x squared plus 10x plus 7, and we need to find the vertex first. So we remember that vertex is the opposite of b over 2a, comma, f of the opposite of b over 2a. So whatever the y value is when x is this. Okay, so let's do that. We have opposite of b, so we get opposite of positive 10 over 2 times a, which is 2. So we get 10 over 4, or negative 10 over 4, which is negative 5 over 2. So we get our vertex. X coordinate of our vertex is negative 5 halves. or negative 2.5, depending on who you are. And we need to plug that number in to get our x or our y value. So we get 2 times 5 halves squared plus 10 times 5 halves plus 7. All right, we get 2. You just have to bear with the work here because this is how this works. So we get 5 halves squared, which is 25 over 4, plus 10 times 5, which is 50, divided by 2, which is 25, plus 7. So if you did this in your calculator here, 2 times 25 is 50, divided by 4 is a 12.5. Oops, I forgot my negative in here somewhere. Here's a negative 5 halves. Shucks. So this should be a minus 25. So minus 25 plus 7 is a minus 18. And 12.5 minus 18 is a negative 5.5. All right, so that means our vertex. Let's go ahead and put these both in decimals because I know that'll make a lot of you happy. This would become a negative 2 point... Oh, man, what's going on here? 2.5, comma, negative 5.5. All right, so we can actually go ahead and put this straight into vertex form. The a value is the same a value that is in your original function. So the a value is 2 times x minus negative 2.5, which makes a plus 2.5 quantity squared, and then the minus 5.5. And that is vertex form for this function in standard form. All right. I have one more on this page because I want us to know how to do this, put this stuff in vertex form. So again, we need to find the vertex. So this is going to be a negative 12, or the opposite of 12, over 2 times negative 3, opposite of b over 2a. So I get a negative 12 over negative 6, which is a positive 2. All right, so we get a nice 2 for our x-coordinate. Then we need to plug that in. 2 squared is 4, plus 12 times 2, which is 24. And we can simplify from there. We get a negative 12 plus 29, which is a 17. So this problem was a little bit faster because all the numbers came out to whole numbers. And we get to go straight into vertex form from there. My a value is a negative 3. And this is x minus a positive 2. And I have a plus 17. And there we have vertex form of this standard form. All right, what if we wanted to go the other direction? The other direction is actually, I think, a lot easier. This is starting with the FOIL method and distribute if necessary, and then simplify. So this is our problem. We have 2 times the quantity x plus 4 squared minus 7. And if we were to expand this, you have to remember that this squared means multiplied by itself twice. So this is why the FOIL method was important. So we have to say it's 2 times whatever we get when we FOIL this. We get x times x, which is x squared, plus 4 times x, plus 4 times x, plus 16, and minus 7. So notice here I said FOIL and distribute if necessary. So the distribution is necessary in this case because we have a 2 on the outside. I'm going to rewrite this as 8x because that's what it is. If I distribute the 2, I get 2x squared. Then I get 2 times 8x, which is 16x. And I get 2 times 16, which is 32, minus 7, and we get the value, or the function now in standard form as 2x squared plus 16x plus 25. And that's it. That is it. That is now in standard form. It is a quadratic. If we were to look, our quadratic term is 2x squared. Our linear term is a 16x. And our constant term is a 25. All right, last piece here is writing an equation from a graph given a vertex and another point. So we're going to use the vertex in vertex form. We're going to write those numbers in, and we're going to use the other point to calculate a. So what I mean here is we have y equals a times x minus h plus, or squared, plus k. And on this, we have the value of h, we have the value of k, and we have another x, and we have another y. So we can actually plug all 4 of those values in for y, x, h, and k, and we can solve for a from these given points. So we're going to do that. We're going to plug in y as -4. We don't know what a is yet. We know x is 5. We know h is 3. And we know k is a positive 4. And we can do some simple algebra to solve this. If I was to go ahead and subtract 4 from both sides here, I would get a -8, if I can get this thing to write. At a -8 is equal to a times 2 squared. 2 squared is 4, so if I divided both sides by 4, I get a is equal to -8 divided by 4, which is a -2. And you should expect a -2 because this is a downwards parabola, or you should expect negative. And we can now write in vertex form a, which is -2, times x minus h, which is 3, plus k, which is a 4. And there we have our equation. All right, that is going to do it for today. I hope you learned something, and I hope you paid attention. I will see you guys later.